Okay, so this is the question here, right? So you are given the program. Okay, so in this program here, you can see here you have the push and pop instruction. So now you know that this one is belong to stack pointer lah. Okay, because the push and pop instruction only used in the stack pointer. Okay, so based on this instruction, you're going to find out what is the value for each of these registers, as well as the value inside of this stack ataupun inside of this RAM, as well as the stack pointer addresses. Okay, it's given that this is the initial value given R16 0, R17 0, R18 0, and then the stack pointer already pointed to address 085F, and then the content inside of this 085F is 0. Okay, that is the initial value lah. Okay, and then the first line here, okay, what you're going to do is you're going to do a load I R16 5. So what happened here, you're going to put 5 to your R16. Okay, so according to this table here, all the value inside of this table must be in hexadecimal. So you need to convert the answer into the hexadecimal. Okay, since this one here, okay, this number here, nombor ni tak ada any symbol in front of this number, so you know that this is belong to decimal number. So what you need to do is you need to convert this number 5 to hexadecimal, which is sama dengan 05. Betul ya? Okay, next we go to simpan. Okay, which is simpan ni actually a label lah, a label for this instruction push R16. Okay, so this one step pointer masih lagi 085F. Okay, by right, you just write down all the changes only. Okay, the thing that have no change, okay, you just leave it blank. Okay, because we know that okay that one the value remains. Okay, tak berubah. Okay, next push R16. Okay, so what you're going to do now is you're going to push R16 value to your stack. So kita lukis dulu gambar kita punya stack. Okay. So this is your stacks. Okay, so now currently your stack pointer point to this one. Okay, but somehow, okay, so now after you execute this instruction here, push R16, so what happened is the stack pointer will decremented by 1. So stack pointer, okay, will point to this address 085E. Okay, and then you, what we call here, you put the value from R16 to your stack. So what happened here, so stacks here akan jadi 05. Okay, 05, and stack pointer is decremented by 1. And then after that, okay, the third line here, okay, you're going to decrement R16. So R16 value become 4 after you decrement R16, and branch not equals simpan. Means that if R16, okay, you are going to look, is it R16 sama dengan R16 sama dengan 0? If not, okay, you go to simpan. If yes, then you exit the loop lah. Okay, you going to do the instruction number 5, 6, and onwards. Okay, so since the R16 is a 4, so you go back to your simpan, push again your R16. So R16 value now is 4 lah, because you already decreased. So 04, put to your stack, and what happened here? Your stack pointer decremented by 1. Okay, so stack pointer point to address 085D, decrement R16, so R16 become 3, not equal to 0, go back to simpan, push again, so 03 will be stored to this address 085D, step pointer decremented by 1. Okay, so this is your step pointer decremented by 1, and then you decrease again your R16, so R16 now become 2. Okay, again R16 not equal to 0, so you go again to simpan, jump again to simpan, push R16 02, and step pointer decremented by 1. Okay, and then what happened here is you decrement R16 become 1. Okay, and then since R16 not equal to 0, you branch again to simpan, push R16 to this address 085DB, and step pointer decremented by 1, and lastly you decrease your R16, so R16 now become 0. Once R16 become 0, so what happened here is you exit from this loop, do the pop R17. So now you're going to write down the final answers here lah. Okay, so the final answers here would be, okay, so this one, after you push R16 here becomes 01, and when you decrement R16, so R16 become 00, and then what happened here? Step pointer point to what address? 085A, 085A, and the content inside of your stack content here is 085B consists of 01. So this is the answer that you should return after right before you exit the loop. Okay, the simpan loop here. Okay, next. Then you pop R17. So what happens when you pop? Okay, you retrieve this value here from the stack and put to your register. So 01 put to R17. So this one got 01. And then what happened to your step pointer? Step pointer incremented by 1. Okay, then you pop again R19. So 02 will go to your R19. So here step pointer point to 08. That is just now is 085B. Now this one is 085C, which is after you pop, okay, after you retrieve this number here from the stack, so stack pointer will incremented by 1. Okay, and then you pop once more to R18, so 03 will go to your R18. And what happened to your step pointer? Step pointer incremented by 1, so step pointer now point dekat address 085. And last but not least is another pop R20. So this one here, this value 04 will go to your R420, and the step pointer incremented by 1. Okay, so this is the answer that you should provided in this box. Okay, if you correctly provided this answer here, you will get 10 marks. Okay, any question? Ada soalan tak kat sini? Okay, if no question, then we go to another, what we call here, okay, we'll see another exercise. Okay, so this is the answers, okay, for the previous exercise. And then we're going to see here. Okay, this is for module 6. Okay, can you do this one? Boleh tak? Buat yang ni dulu, and then after that we discuss the answers. Okay, I give you, for this one, I give you around 10 minutes. If you are going to ask this kind of question, okay, because this one involving the data rotation, so I advise you to convert this value, okay, R17 and R18 value to binary numbers. Okay, once you convert this to binary number, then after that you can do this rotation. Okay, arithmetic shift right and logical shift right. Okay, for those who don't know how the ASR and LSR works, okay, you may find in the data set instruction. Okay, so refer to your data, okay, instruction set summary. Okay, so this is the instruction set summary. You find the, okay, find out the ASR and LSR instruction. Okay, as you can see here, for the ASR, so this is the ASR. It says that, okay, from this operation here, you know lah, dia punya what happens after you execute this instruction. Okay, it says that for this one here, okay, RDN plus 1 will go to your Rn, in which n equal to 0. So you lukis dulu lah. Okay, so lukis dulu ASR, which is sama dengan, okay, you lukis you punya bit. Okay, so this is a bit kosong and this is a bit 7. Okay, it says that RDN plus 1 will go to Rn. Let's your Rn is 6. Okay, RDN is 6. So what happened here? RDN plus 1 with 7 will go to RD 6. So you know that this one will go to here and the rest will follow, shifted to the right by 1 bit. What happened to bit 7? Bit 7, no change. Okay, the other bit will change, but bit 7 you copy back the number. This is what the ASR do. And then for the LSR, so this is the LSR. Okay, by looking at this operation here, okay, you know that, okay, now R0, okay, RD0, okay, you lukis dulu lah. Okay, so 07, this is for LSR. It says that RD0, so this is a 0, will go to C. Okay, and then 0 from outside will go to RD7. Okay, so 0 from outside go to bit 7 and the rest will shifted to the right by 1 bit. Okay, so now we are going to what we call here, find out what is the answer after you execute each of this line. So the first line here, LDI R70 EF. So what happened here? R17 sama dengan EF. So this one R18 sama dengan 94. Okay, and then ASR R17. Okay, so as I mentioned earlier, okay, you're going to what we call here to change this hexadecimal to binary. Tukar dulu, convert dahulu daripada hexa to binary. So this is your EF. Okay, tukar ke what we call here binary, which is equal to 1110 1111. This is for the ES lah. Okay, and then for R18, which is 94, so this is R18 94. Change to binary, convert to binary, you will get 1001, and then 4 is 0100. Okay, and then do the SR for R17. So this is R70, you do the SR instruction. So this one copy back and the rest will shift to the right by 1 bit. So 1 1 1 0 1 1 1. And what about this one will go to your, okay, this one go, okay, just go outside je lah. Okay, because dia punya output from output 0 not going to your C. Okay, so you just leave like that. Okay, just like that. And then next, for 94, okay, you do the LSR, which is LSR. Mana kita punya LSR? So this is your LSR 0 Okay, 0 from outside go to your bit 7. Okay, and then the rest will shift to the right by 1 bit. Okay, so dia akan jadi kosong. Sorry, 1, 0, 1, 0, 0, 1, 0, 1, 0. What about this 0 here? This 0 akan masuk kepada kamu punya C. Okay, so what will be the what we call here the value here? So this one now become F. F berapa ni? F7. Okay, what about this one? This one will become berapa ni? 4A. Betul tak? Okay, because I don't have answers schema for this one. If my answer is same as you, then betul lah. Okay, next, what you going to do? Store this value here to address pointed by Y. So address 300. Okay, you will store F7 and then address and then Y plus, yeah. So the Y will increases by 1. Okay, so now address 301 you will store berapa? 4A. Okay, and then you do get ASR R17. So buat lagi sekali. This one copy and then shift to the right by 1 bit. Okay, what about this one here? Sama juga. Okay, kosong masuk ke bit 7 and then you shift to the right by 1 bit. So 01, 01 and then kosong will go to your C and find out what is the value. So this one is F berapa ni? 8 tambah 2 tambah 1 which is 11. 11 convert to hexa equal to B. And what about this one ya? This one is 2 plus 4 plus 1 which is equal to 5. Okay, and then you store again. Okay, by using the indirect addressing mode. So yang ni tadi your Y already increases to 302. Okay, so you store 302 with what number? FB. And then Y increased by 1. So Y now point to address 303. Okay, so 303 at address 303 you store again with R18 which is to 5. And then the Y will increase by 1. Betul tak? Betul tak jawapan saya ni? Correct or not? Okay, correct. Bagus. Next. Okay, you do one more. Buat lagi sekali sampailah habis. Okay, tak apalah kita buatlah. Okay, so buat lagi sekali ASR again. Copy. Shift to the right by 1 bit. Okay, what about this one here? Sama juga. What you're going to do is here is kosong daripada luar masuk bit, go to your bit 7 and then the rest you will shift to the right by 1 bit. Okay, so this one here will go to your carry. Okay, so what would be the results here? Kat sini you will get F 8 tambah 4 which is 12 tambah 1 13. What is 13? A, B, C, D. Okay, so FD. And what about this one here? This one is 1, 2. Okay, and then store to your Y which is a 304. You will store FD and then at 305 you will store 1, 2. Okay, do once more. This is the last process. Okay, copy back 1 1 1 1 1 0. And what about this one? Sama juga. Kosong will go to your bits 8 and then the rest will be shifted to the right by 1. And this kosong here will go to your C flat and then get the hexadecimal value. So this one is F E And what about this one here? 09. Okay, and then you store to this this address that pointed by Y. So now Y is pointed to address 306, and the value you store here is FE, and increment Y by 1, so Y point to address 307, and it will store value 09, and the Y now point to what address? What is the latest address that pointed by Y? Is it 307 or 308? Okay, 308. Okay, after you store the value from R18 to this address, then you increment your Y. So Y is 308. Okay, so I think that's all for today. Any question? Ada soalan tak? Okay, actually we have another examples here. Exercise. Okay, this one not covered in your test 2 because this already covered in test 1. Okay, this one here will cover in your test 2. Okay, for the test, okay, the test will cover from module 5 to module berapa tadi? Module 8. Okay, modul 5 sampai modul 8. Okay, any question? Are you going to do this one? Nak buat yang ni tak? Or you going to call it a day? Okay, we stop here. Do lah, sir. Okay, can you do it by yourself, and then nanti in the next class I will give you the answers. Boleh tak? And then we compare. Okay, class. Thank you. See you next week.